Hello students, welcome to another video. So today we will be solving Pure Maths paper 1 from May-Jun 2017, variant 13. Now let's look into the first question. Question number 1, it says the coefficients of x and x square in the expansion of 2 plus ax to the power 7 are equal. Find the value of the non-zero constant a. So let's first find the coefficient of x. So in order to find the coefficient of x, that means we need to find the coefficient of x to the power 1. We know that if we have 7c1, then ax will have the power 1. So this will be 7c1, 2 to the power 7 minus 1, which is 6, and ax to the power 1. 7c1 is 7, and 2 to the power 6 is 64, and ax to the power 1 is ax. So that gives us 448 ax. The coefficient of x square can be found if we consider 7c2, because this 2 will become the power of ax, which will leave us with ax square. A square is x square. So 7c2 is 21, and 7 minus 2 is 5, so 2 to the power 5 is 32, a square x square. So the coefficient of x square is 672 a square. Since they say in the question that the coefficient of x and x square are equal, so according to the question, 448a is equal to 672a square. These are just the coefficients. Therefore, 672a square is equals to 448a. So if we take away a from both sides, because the question has stated that a is a non-zero constant, a cannot be 0. Therefore, we can cancel out a from both sides. And we are left with 672a is equals to 448. Therefore, a should be 448 over 672. So, a is 2/3. Question number 2. The common ratio of a geometric progression is r. The first term of the progression is r square minus 3r plus 2. And the sum to infinity is s. We need to show that s is equals to 2 minus r. We know that the sum to infinity, the formula for sum to infinity is a over 1 minus r. So for this particular question, we have sum to infinity is defined by just s, and a is, which is the first term, r square minus 3r plus 2, and the common ratio is r, so it will be 1 minus r. If we middle term this equation, it will be r square minus 2r minus r plus 2. If we take the factors for this equation, then it would be r minus 2 and r minus 1 over 1 minus r. Now, what we also can do, we can take minus common from this factor, and we can write it as minus within brackets 1 minus r, and we will leave r minus 2 the way it is. And we have 1 minus r in the denominator as well. So then we can cancel out 1 minus r and 1 minus r from both sides. So we are left with minus r minus 2. So if we expand the brackets, then it will become 2 minus r. And that is what we needed to show. In part 2, it says find the set of possible values of s, values that s can take. So we know that for sum to infinity to exist, the common ratio must lie between minus 1 and positive 1. So when we substitute these two values for the proof that we have provided earlier, which was s equals to 2 minus r, so I'm substituting the value negative 1 into r, so that gives us 2 minus minus 1. And when I substitute 1 into that equation, it will become 2 minus 1. So simplifying it, we get 3 and 1. So the set of possible values that s can take will be between 1 and 3. S lies between 1 and 3. Question number 3, it says find the coordinates of the points of intersection of the curve y equals to x to the power 2/3 minus 1 with the curve y equals to 1/3 x to the power 1/3 plus 1. So for the point of intersection, we need to equate these two equations, y equals to y. That means x to the power 2/3 minus 1 is equals to x to the power 1/3 plus 1. Or we can say x to the power 2/3 minus x to the power 1/3 minus 1, and if we bring this over to the left hand side it will become minus 1. So minus 1 will be minus 2 equals to 0. Now let's consider a to be x to the power 1/3. If we consider a is to be x to the power 1/3, then it forms a quadratic equation. So a square, because we have x to the power 2/3, so if we consider a to be x to the power 1/3, so when you square it you get 2/3. So that means a square minus a minus 2 is equals to 0. So if we do middle term, it will be a square minus 2a plus a minus 2 equals to 0. If we take a common, we have a minus 2 plus 1, a minus 2 equals to 0. So the factors will be a plus 1 and a minus 2 equals to 0, which means a is -1 and a is positive 2. Or we can say x to the power 1/3 is equals to -1 and x to the power 1/3 is equals to 2. So if we multiply the powers by 3 on both sides, we will be left with x equals to -1 and x equals to 8. When x equals to -1, we need to find the coordinates. So we need to substitute this value into one of the equation. So y will be -1 to the power 1/3 plus 1. So that gives us y equals to 0. And y is equals to 8 to the power 1/3 plus 1, which gives us y equals to 3. So the coordinates are -1, 0, and 8, 3. Question number 4 is not in the syllabus at the moment. Question number 5, it says, show that the equation 2 sin theta plus cos theta over sin theta plus cos theta equals to 2 tan theta. This can be expressed as cos squared theta equals to 2 sin squared theta. So let's deal with this equation. If we cross multiply, we get, when cos theta is multiplied with this whole equation, this will become 2 sin theta cos theta plus cos squared theta equals, this 2 sin theta will get multiplied with sin theta plus cos theta, which gives us 2 sin squared theta plus 2 sin theta cos theta. Since we have 2 sin theta cos theta on both sides, we can cancel them and we are left with cos squared theta equals to 2 sin squared theta, which was required to express. In part 2, it says, hence solve the equation 2 sin theta plus cos theta by sin theta plus cos theta equals to 2 tan theta for theta lies between 0 and 180 degrees. We know that we have already expressed this equation into this form, cos squared theta equals to 2 sin squared theta. So using this method will be easier for us to figure out the values. So we can rewrite it as 2 sin squared theta equals to cos squared theta. Or we can say sin squared theta by cos squared theta will become tan squared theta and 1 by 2 will become half. So tan squared theta equals to half. That means tan theta will be square root of half, which will be plus minus 1 over root 2. Now let's find the basic angle. So alpha, which is the basic angle, is equal to tan inverse of positive half. So that gives us the basic angle, which is 35.264. Now let's figure out where positive tan lies. Positive tan lies when it's in the first quadrant and in the third quadrant. And negative tan lies when it's in the second quadrant and fourth quadrant. So since our limit for the theta lies between 0 and 180, that means we can only take the first quadrant and the second quadrant. So the first quadrant, the actual angle will be the basic angle, which is 35.3, and the second quadrant, it will be 180 minus the basic angle, which is 144.7. Question number 6. The line 3y plus x equals to 25 is a normal to the curve y equals to x square minus 5x plus k. Find the value of the constant k. So 3y plus x equals to 25, y equals to x square minus 5x plus k. We can say 3y is equals to minus x plus 25, or we can convert this into the format which is y equals to mx plus c. So y is equal to minus 1/3 of x plus 25 over 3. So the gradient of the tangent is equals to 3, because the gradient of the normal is minus 1/3. that means gradient of the tangent will be minus 1 by this gradient, which will give us positive 3. So we know that the equation of the curve is y equals to x squared minus 5x plus k. If we differentiate this equation, we get the equation of the gradient for the tangent of the curve. When we differentiate y, we get the equation of the gradient for the tangent of the curve. So dy by dx is equals to 2x minus 5. So since the gradient of the tangent is 3, let's figure out that when the gradient is 3, what will be the x coordinate? So that means 2x minus 5 is equals to 3. Therefore 2x is equals to 8, so x is equals to 4. That means when x is equals to 4, the gradient of the tangent is 3. Now let's figure out the value of y. So when x is equals to 4, y is equals to minus 1/3 of 4 plus 25 over 3, which is the equation of the normal. Therefore y is equals to 7. So the required point is 4, 7. And since 4, 7 lies on the curve, that means it must satisfy the equation of the curve. Therefore, we know that the equation of the curve is y is equals to x squared minus 5x plus k. So substituting x and y coordinate into this equation, we get 7 is equals to 4 square minus 5 times 4 plus k. Therefore, k will be 11. Question number 7. The diagram shows two circles with centers A and B having radii 8 cm and 10 cm respectively. The two circles intersect at C and D, where CAD is a straight line and AB is perpendicular to CD. We need to find the angle ABC in radians. That means we need to find this angle. So this is pretty straightforward. If you consider this right angle triangle, that means you can use SOHCAHTOA. So we have for this angle, we need to find this angle. So this is opposite to this angle and this is the hypotenuse. So we can use sine ABC is equals to opposite by hypotenuse, which is 8 over 10. So that gives us ABC is equals to sine inverse of 0.8, which should be 0.9273. Make sure that your calculator is in radians because we need to find the angle in radians. In part 2, it says find the area of the shaded region. So let's look into the diagram again. So this is the shaded region that we need to find. In order to find it, what we can do, if we manage to find the area of the semicircle CD, which is this, and then if we take away the area of the minor segment of CD, which is this, then we will be left with the shaded region. Now let's look into it. Angle DBC should be twice of 0.9273. So which one is angle DBC? This is the angle DBC, this part. So we need this because we need to find the area of the semicircle and the segment. We need to find the area of the segment. So area of the semicircle CD is half pi r square, because if circle is pi r square, that means semicircle will be half pi r square, where the radius is 8. Let's look into the radius over here. So as you can see, for the semicircle, if you consider A to be the center, that means AC is 8, which is the radius for the smaller circle. So with the help of this radius, we can find the area of this semicircle. Now, area of the minor segment CD, for this, what we can do, we can use the formula, which is half r squared theta minus sine theta, where radius is 10. So we are taking the radius of the bigger circle. So with the help of this, we can find the area of the minor segment. So area of the minor segment will be half r square theta minus sine theta. And we know that theta is 1.8546 minus sine theta will be 1.8546. So that gives us 32 pi minus 50 times 1.8546 minus sine 1.8546. That will give you 55.8 square units. Question number 8, it says A is minus 1, 1 and B is AB. These are the 2 points where A and B are constants. The gradient of AB is 2. Find an expression for B in terms of A. So what we can do, we know that since they have provided us with the gradient AP, we can use the formula y2 minus y1 is over x2 minus x1. So this, I'm considering this to be the y2. So y2, b minus 1 over a minus minus 1 is a plus 1 equals to 2. So b minus 1 is equals to 2a plus 2 if you cross multiply them. So b will be equal to 2a plus 3. So we have just expressed b in terms of a. In part 2, it says B has coordinate 10 and negative 1 is a third point such that AP is equals to AB. We need to calculate the coordinates of the possible positions of P. So let's first have our coordinates in front of us. So A was negative 1 and positive 1. B was 10. B is 10 and negative 1 and P is AB. So let's find the length of AB. In order to find the length of AB, we can use the formula square root of x2 minus x1 whole square plus y2 minus y1 whole square. So this will be 10 minus minus 1, which is 10 plus 1 whole square plus minus 1 whole square. That gives us 5 root 5. Or we can say AB square is 125. Now, AP, in order to find the length of AP, what we can do, we can write square root of a plus 1 whole square, again x2 minus x1. So a minus minus 1 will become a plus 1 whole square plus b minus 1 whole square. So this gives us a square. We can write it as ap square is equals to a square plus 2a plus 1 plus we can substitute b as 2a plus 3, which we have expressed previously. 2a plus 3 minus 1 whole square, or we can write it as a square plus 2a plus 1 plus 2a plus 2 whole square. So this will become a square plus 2a plus 1 plus 4a square plus 8a plus 4. Simplifying it further will get us 5a square plus 10a plus 5. So since it's mentioned in the question that AP is equals to AB, we can also say that AB square equals to AP square. We're just squaring both sides. By doing that, we get that AB square is 125 and AP square is this. So that gives us 5a square plus 10a minus 120 equals to 0. By dividing both sides by positive 5, we get a square plus 2a is minus 24 equals to 0. Or we can do middle term by a square plus 6a minus 4a minus 24 is equals to 0. If we take a common, it will become a plus 6 and minus 4 will give us a plus 6 again. So the factors will be a minus 4 and a plus 6 equals to 0. Therefore, a is positive 4 and a is negative 6. Now, since we know the value of a, we can substitute these two values into the expression of b, and that will be 2 times 4 plus 3, which is 11, and 2 times negative 6 plus 3, which is negative 9. So P could be 411 or negative 6, negative 9. Question number 9, it says express 9x square minus 6x plus 6 in the form of ax plus b whole square plus c, where a, b and c are constants. We can see that this is a completed square form. So what we can do, we can take 9 common from these two and we get x square minus 6 over 9x plus 6. We can simplify it a bit further. So this will become 9 within brackets x square minus 2/3 of x plus 6. Now let's do the completing square for this bit only. So we keep the 9 outside and we put a second bracket, and then we have x minus 2 over 6 because we are dividing 2/3 by 2, which will give us 2 over 6. So 2 over 6, we close the bracket whole square, minus 2 over 6 whole square plus 6. This can be written also as x minus 1/3 whole square minus 2 by 6 is 1 by 3. 1 by 3 whole square is 1 by 9. plus 6. Make sure that you're using the appropriate brackets where necessary. Then when you take away the brackets, the second brackets, after you're done squaring this, what you get is 9 times x minus 1 by 3 whole square minus 9 times 1 by 9 will be just 1 plus 6. So this will become, we can write 9 as 3 square and then x minus 1 by 3 whole square plus 5. So the reason why I have squared this so that I can multiply 3 with all the elements inside, because these two have the same power. So this will become 3x minus 3 times 1/3 is just 1, bracket closed, whole square plus 5. So we have just expressed the equation in the form of ax plus b whole square plus c. In part 2, it says the function f is defined by f of x equals to 9x square minus 6x plus 6 for x is greater or equal to p, where p is a constant. State the smallest value of p for which f is a one-to-one function. That means we need to understand the x coordinate of the turning point. So with the help of the completing square, we can see that the smallest value of p should be 1/3, because when 3x minus 1 is equals to 0, x will be 1/3. And if x is greater than 1/3, we can have a one-to-one function. Otherwise, this whole equation is a many-to-one function because it's a quadratic function. In part 3, it says for this value of p, obtain an expression for f inverse of x and state the domain of f inverse. So f of x is 3x minus 1 whole square plus 5. And always remember that when you are trying to do the inverse of the function, and if you have a quadratic equation, you must convert the quadratic equation into completed square form first. And for this specific question, we already have done it before. So we simply now can state that f of x is 3x minus 1 whole square plus 5. So let's consider y to be f of x. So y can be then 3x minus 1 whole square plus 5. Let's make x the subject from this equation. So in order to do that, we can first make 3x minus 1 whole square the subject equals to y minus 5. So 3x minus 1 is equals to plus minus square root of y minus 5. So 3x is equals to 1 plus minus square root of y minus 5. So x should be, by dividing both of them by 3, we get 1/3 plus minus 1/3 of y minus 5. F inverse of y is equals to x. So f inverse of y is equals to 1/3 plus minus 1/3 square root of y minus 5. So f inverse of x should be 1/3 plus minus 1/3 root over x minus 5. But since we know that x is greater or equal to 1/3, that means we cannot take negative. We cannot be having 1/3 minus 1/3 of square root of x minus 5. So our final answer should be 1/3 plus 1/3 of square root of x minus 5. That will give us a value which is greater than 1/3. Now we are left to find the domain of f inverse. So we know that the domain of f inverse should be the range of f of x. So let's find the range of f of x. So we know that x is greater or equal to 1/3. So when we substitute the value of x as 1/3, we get f of x is 5. So that is the range of f of x. That means the domain of f inverse is x is greater or equal to 5. In part 4, it says state the values of q for which the equation f of x equals to q has no solution. That means if q is less or equal to, if it's less than 5, not equal to, if q is less than 5, it will have no solution, because it must be 5 at least. Question number 10, it says figure 1 shows part of the curve y equals to x square minus 1 and the line y equals to h, where h is a constant. The shaded region is rotated 360 degrees about the y-axis. Show that the volume of the revolution v is given by v is equals to pi half h square plus h. So we have the equation of the curve, which is y equals to x square minus 1. Now let's make x squared the subject of the equation because it will be rotated about the y-axis. So x square equals to y plus 1. So the volume should be pi integrating with upper limits h and 0 x square dy. So pi x square is y plus 1. Now if we integrate y plus 1, we get half y square plus y, and the limits are h and 0. So when we substitute h and 0 into this equation, we get h square by 2 plus h minus 0 square by 2 plus 0. So this whole thing will become 0, and we are left with half h square plus h. So v is equals to pi half h square plus h. In part 2, it says find, showing all the necessary working, the area of the shaded region when h is equals to 3. So y is equals to x square minus 1. X square is equals to y plus 1. That means x is equals to square root of y plus 1. So x can also be written as y plus 1 to the power half. If we integrate x with respect to y, because we need to find the area of the shaded region. So x is y plus 1 to the power half. Now we have power as the operator, so we need to differentiate the elements within the brackets. So that will give us 1. So what we can do then, we can now integrate the power. So that will be half plus 1 is 3 by 2, and y plus 1 over 3 by 2 will give us 2 y plus 1 to the power 3 by 2 over 3 plus c. Now we need to integrate with limits, so we can ignore c. So the limit is 3 and 0. Let me show you the diagram again. Now we are trying to find the area of the shaded region along the with the help of y-axis. So the limits will be 0 and 3. So h is 3. So that's why we are integrating x with respect to y. So when we substitute 3 and 0 into the equation, we get 2 within brackets 3 plus 1 to the power 3 by 2 over 3 minus 2 within brackets 0 plus 1 to the power 3 by 2 over 3. That gives us 16 by 3 minus 2 by 3, which is 14 by 3. In part B, it says figure 2 shows a cross section of a bowl containing water. When the height of the water level is 8 cm, the volume V cm cube of water is given by V is equals to pi 8 square plus 8. Water is poured into the bowl at a constant rate of 2 cm cube per second. Find the rate in centimeter per second at which the height of the water level is increasing when the height of the water level is 3. So in order to solve this question, we are provided with the volume, which is volume in is 2 centimeter cube. We need to find the dH by dt, and we are provided with the height, which is 3. So dH by dt can be found with the help of the chain rule, which is dH by dV into dV by dt. So dH by dV should be pi h square by 2. Okay, so this is how we can manage to find dH by dt. dH by dt should be dH by dV into dV by dt. But first, we need to find how we can get dH by dV. V is equals to pi h square by 2 plus h. That is V. So dV by dH will be 2 times pi by 2. When you bring the power to the left hand side, you get just pi h, and h to the power 2 will become 2 minus 1, which is just 1. So it will be pi h. And differentiating pi h will give us just pi. So that is dV by dH. Now we can substitute this value into this equation. So dH by dt will be equal to 1 over pi h plus pi times 2, which is the volume in. And the reason why we did the reciprocal of this equation, because we found dV by dH, but we are required dH by dV. So we had to do the reciprocal of this equation. So now when h is equals to 3, dH by dt should be equal to 2 over pi times 3 plus pi. So that will give us 2 over 4 pi, or we can say 1 over 2 pi, which is 0.159. Question number 11. The function f is defined for x is greater or equal to 0. It is given that f has a minimum value when x equals to 2, and that f double prime x is equals to 4x plus 1 to the power minus half. So f prime x, let y is equals to f double prime x. So y is equals to 4x plus 1 to the power negative half. So integrating y with respect to x is equals to 1/4. For this, what we need to do, in order to integrate this, we must take power as the operator. So we need to differentiate the elements within the brackets. So that will be 4. So we can bring 4 over here after differentiating, and we can balance the equation by having 1/4 outside. After that, we can integrate the power. So minus half plus 1 will give us positive half. So positive half over the power that we got, half. So that will give us 1/4. So 4 into half will give us 2. So half within brackets 4x plus 1 to the power half plus c. Now this is what we got by integrating this equation. So f prime x is half 4x plus 1 to the power half plus c. It's given that f has a minimum value when x equals to 2, and we know that we get minimum value, which is a stationary point. That means f prime x must be 0 when x equals to 2. So f prime x is equals to 0 when x equals to 2. So we simply substitute these two values into the equation, and we get 0 is equals to half, and 4x will become 4 to the 8, so 8 plus 1 to the power half plus c. So that will give us c to be minus 3 over 2. So the equation of f prime x should be half of 4x plus 1 to the power half minus 3 over 2. Part 2 of the question, it says, it is now given that f double prime is equals to 0, f prime is equals to 0, and f of 0 are the first three terms respectively of an arithmetic progression. Find the value of f of 0. So f double prime 0 must be f 4 times 0 plus 1 to the power negative half. That gives us 1. F prime 0, when f prime 0 is for f prime x, when x is equals to 0, we will be getting half within brackets 4 times 0 plus 1 to the power half minus 3 over 2. That will give us half minus 3 by 2, which is negative 1. So since it has already stated that this is an arithmetic progression, we have nothing to prove. So that means there is a common difference. So the common difference should be next term minus the previous term. So next term, f prime 0, and the previous term is f double prime 0. So next term is minus 1 and the previous term is 1. So next term minus previous term is negative 2, and that is the common difference. So f of 0 means the third term. So how do we get the third term? By adding the common difference. So minus 1 is our second term, plus the common difference, which is minus 2, will give us minus 3. And that is the value of f of 0. And we managed to find it with the help of the arithmetic progression. In part 3, it says find f of x and hence find the minimum value of f. So f of 0 is minus 3. F prime x is half 4x plus 1 to the power half minus 3 over 2. So let's consider y to be f prime x. So y is equals to half 4x plus 1 to the power half minus 3 over 2. Let's integrate this equation so that we get the f of x equation. So integrating y with respect to dx is equals to integrating half of 4x plus 1 to the power half minus 3 over 2 dx. Then we can take away half, which is the constant, outside the integration, and then since power is the operator, we need to differentiate the elements within the brackets. That gives us 4. So we bring the 4 here and we balance the equation by having 1 by 4 outside. And this will become 3 over 2x. By integrating this, we get 3 over 2x. Now, what we can do, we can integrate the power. So this will become half plus 1, which is 3 by 2, over 3 by 2. And simplifying it further, we get 4x plus 1 to the power 3 by 2 over 12, minus 3x by 2 plus c. In the previous part of the question, we found that f of 0 is equals to negative 3. So with the help of this, we can find the constant. So f of 0 is negative 3. That means we can substitute the value 0 into x and we get 0 plus 1 to the power 3 by 2 over 12, because 4 times 0 will be 0 and 3 times 0 will be 0. So 0 plus 2 plus c is equals to negative 3. So simplifying this, we will get 1 plus 1 by 12 plus c is equals to negative 3. And if you simplify it further, you will get c is equals to negative 37 over 12. So f of x must be 4x plus 1 to the power 3 by 2 over 12 minus 3x by 2 minus 37 by 12. So what we are still required to find is the minimum value of f. We need to find the minimum value of f. And we know that the minimum value occurs when x is equals to 2. The minimum value occurs when x is equals to 2. That means we need to substitute x equals to 2 into the equation of the curve, which is f of x. So when x is equals to 2, 4 to the 8 plus 1 to the power 3 by 2 over 12 minus 3 to the 6 by 2 minus 37 by 12. That gives us f of x is negative 23 over 6. And that is the minimum value, which is negative 23 over 6. And that will be all for now. I will see you in the next video.